Welcome everybody to the September shared Boulder Java Users Group and Denver Java Users Group meeting. I'm your host, Greg Ostrovich, the president of the JUG. I'm going to go through a few announcements and then we'll bring up our speaker. So first of all, a reminder, we're always looking for speakers and content and topics. So if you have a topic you're interested in, please reach out to myself or Matt Rabel or hit us up through the Meetup site. And we're happy to try to seek out other speakers if you have somebody in mind or if you'd like to speak. I'm going to do our usual housekeeping announcements, which are if you need the restroom, you're logging in from home or work or something, and hopefully you can find one. Tech Systems sponsors the food, which we appreciate since we've been doing this from COVID. Tonight's dinner is sponsored by whatever's in your pantry or your fridge. Andrew Rawson and Courtney at Tech Systems are contacts there. Please reach out to them if you have a need, if you're looking for a job or you're looking to hire a company to help you fulfill that job. JFrog, another sponsor, and they usually do a monthly sweepstakes, and we appreciate their support. Apex Systems is our beer sponsor, but again, tonight's beers are sponsored by whatever's in your fridge. I brought something for tonight. Develop Intelligence is another sponsor of ours. They give out Pluralsight training. Ace Venwancil is our contact there. They're usually looking to hire technical instructors who specialize in several technologies for contract opportunities. Those include Java, Golang, JavaScript, React, DevOps, tools like Kubernetes and Docker, and many others. Reach out to Jarrett, J-E-R-E-T, at developintelligence.com. Amazon is another sponsor of ours, and that's our contacts are Chris Almond or Sam Ayer there, and we appreciate their support. Okta, which is who Matt works for, is not only the sponsor, they give away stuff, but they're the Meetup site sponsor and for these online meetings we've been doing, and we really appreciate their support. Check them out. They provide some OAuth stuff, tools, and some other things. Go check them out. NextGen is another agency, like a staffing agency. Beth.Crowley, C-R-O-W-L-E-Y, at nextgeninc.com, and they usually give us a Amazon gift certificate for $50 that we give away every meeting. If you're interested, reach out to them at nextgeninc.com. They don't have any Java openings right now, but things can change, and we appreciate their support. AgileLearner.com is another sponsor. That's Venkat Subramanian's company. And we're offering a subscription to AgileLearner.com through him. He also has a technical conference that had to be delayed, and they're going to get that rescheduled. So, JetBrains is another sponsor. We give away a couple of IDEs from them. So we really appreciate their support and just wanted to give them a shout out. So a big thanks from me to the people that make these things possible, and they do all the work. So Matt Rabel for getting our speakers, our locations, and running the online meeting. Mike Zuedo handles all the door prizes and some of that operational stuff. Zeddy Chinfong also handles operational stuff, including social media, announcements, etc. The reason I've been doing this for so long is because I'm not doing it alone, and I just really appreciate their support in this. Chris Woyna from the Boulder Java Users Group usually does an announcement. He doesn't have any power right now. He's actually getting a generator to fix that. He apologizes for not being here, but wants to give a shout out to No Fluff Just Stuff and the Uber conference that's coming up. The Uber conferences they support. They do a great job for the different conferences. Also to Tech Systems, which is another sponsor of theirs as well. Finally, before I introduce Josh, I wanted to let you know he is giving away 3 copies of his book tonight, which is Reactive Spring. So tonight's presentation, Josh Long is going to be talking about the RSocket revolution. RSocket is here. RSocket is a binary, reactive, and operations-friendly wire protocol that integrates and builds on top of Project Reactor. Engineers originally developed RSocket at Netflix. Then they moved to Facebook. RSocket was the fledgling project for the Reactive Foundation, of which the Spring team, Lightbend, Facebook, Alibaba, and others are founding members. RSocket represents the operational insight of some of the largest organizations in the world. and it readily integrates with Spring. Join me, Spring developer advocate Josh Long, join Josh in this rapid reactive ride on the RSocket rocket. And we'll look at the rich Spring support for RSocket and its use in building faster, more robust, and more scalable services. The topics of tonight are going to be how to build RSocket-based controllers in a Spring framework, building RSocket clients using the RSocketRequester, how to use the RSC client, build processing pipelines using Spring integration, and securing securing services with Spring security, introducing bidirectional communication, and much, much more. So about tonight's speaker, Josh Long. Josh has been the first Spring developer advocate since 2010. Josh is a Java champion, author of 6 books, including O'Reilly's Cloud Native Java, Designing Resilient Systems with Spring Boot, Spring Cloud, and Cloud Foundry, and the upcoming Reactive Spring, and numerous best-selling video trainings, including Building Microservices with Spring Boot, Livelessons with Spring Boot co-founder Phil Webb, and an open source contributor to Spring Boot, Spring Integration, Spring Cloud, Activiti, and Vaadin. A podcaster, a Bootiful Podcast, and a YouTuber. You can find Josh on Twitter at Starbucksman, STARBUXMAN. And we thank him so much for coming out today virtually to do today's awesome talk. Thanks, Josh.
Yo, can you hear me? Can you see me?
You're all good.
I'm live? All right, good stuff. So I'm in the show. Thank you for having me. I appreciate it. I appreciate the opportunity to be here. I'm live. So, okay. I've never taken before. All right, looks like we're live. Hopefully we're live. Good stuff. I appreciate that. All right, everybody who's joining. Thanks so much for being here. Thanks for the opportunity to be here. Would that I could be there. Huh?
Your audio is kind of weird. Are you using your microphone or?
I'm using my Brio, which should do the trick. Let me check and see if it's configured to the right one. Cam, mic, camera, good. Audio, mic. Test, test, test.
Okay, sounds better now.
Test, test, test. Can you hear me now?
Yep, sounds good.
Okay. Sorry about that. Alrighty, good. Sorry about that, everybody. Like I said, I've never done a presentation before. So I appreciate you all being here. I know that this is kind of an odd circumstance. It doesn't feel, I haven't yet become accustomed to it. And even if I had become accustomed to being locked down at home, trying to avoid the pandemic and being afraid of my groceries, I'm in San Francisco, and today, because 2020, my sky is red. It's orange. I have an orange sky today. Not like, oh, look at that nice sunset orange. I mean, it's been orange all day. It's been dark all day. So, there's that. I'm glad that we're all in it together, and thank you for being here. So we have a lot of stuff to cover today, my friends. So very little time, as always. Grab those coordinates there. There's my Twitter, my email, what have you, and you can find me online. I'm a Spring developer advocate. I'm a Java champion. I'm a Kotlin, GDE, Google developer expert, etc. And that's part of what I do. I used to travel, and people are nice to me, and I do some videos. And I've got an old book called Cloud Native Java that's pretty swell. It's all about how to build applications that survive and thrive in terms of the cloud using Spring Boot and Spring Cloud and Cloud Foundry. I've got a podcast. I've got a blog every Tuesday called This Week in Spring. I've got a screencast series called Spring Tips on YouTube. I've got a new book, which is just published. We just published it now. It's not actually early access. Let me fix that right here, right now. Buy now. There's no early access. It's done. That thing's cooked. I got the final version. It's just trickling through Amazon's Kindle market process, upload process. And meanwhile, it's already on LinkPub, so you can go to that link and you'll find links for all your different territories. You can get it in print in a week or so, and then it's there. So the book is all about reactive programming, and indeed we're going to cover a lot of the stuff that we're going to look at today in that book. But it's okay. Maybe you don't need the book. Maybe it's worthless. Maybe you just listen to what we're going to talk about today, and you got everything you're going to get out of it. Who knows? So we're going to talk about RSocket today, my friends. We're going to talk about reactive programming with RSocket. Now, I've already addressed this group before on reactive programming. I think Matt and I did a demo once or twice or 1,000 times, and I'm assuming that we have some familiarity with reactive programming. But suffice it to say, reactive programming is a changing of the approach to building software. It takes into mind the sort of inverted way that people build software when they're trying to build for more resource efficiency. So what I mean by that more concretely is that if you look at all the things that become involved or become implicated when you start building distributed systems, you have discrete actors moving in independent cadences. You've got some things moving faster than others and at different times than others, and so on. So all of this sort of implies a asynchronous, failure-aware, latency-aware programming model, which our traditional approach to building services does not embrace. It doesn't support. So when you think about RPC, when you think about even REST, right, which is synchronous, it's temporally coupled. You make the request and you get the response at the same time or as soon as possible. It's assumed that you haven't disconnected before you get the response. So when you look at all those kind of limitations, that doesn't work in a very sort of modern microservices world, right? And so the real sort of paradigm shift for me in my generation, in my time, short and modest though it is that in the last 15, 20 years, we sort of seem to embrace the reality that things are going to fail and we build accordingly. Failure is going to happen. It's not about trying to avoid it because that can't be done. It's more about making sure that you build software that does the right thing in the face of failure. And so reactive is a response to that, right? Reactive originally was a set of design principles that applied to, on the same computer kind of behavior. What happens when you have, for example, a click stream of events and you want to be able to respond to that stream of events as opposed to trying to react to each individual distinct event. You want to think about it as a stream of things, right? And then eventually, about 10 years ago, a lot of us, a number of different organizations in the ecosystem, started sort of solving this problem, trying to approach building distributed asynchronous latent services in a consistent way. And eventually all those different stakeholders got together in 2014, I think it was, there was the Jonas Bonner's Reactive Manifesto, right? And that has, what is it now, 30,000 signatories, right? So that clearly there's a momentum behind that. And then eventually a number of the other stakeholders that, believed in and embraced the Reactive Manifesto got together, and we extracted out some common ground types. That's the reactive stream specification. Now, that was in 2014, 2015. These common ground types represent foundational types. They're super, super bare, super Spartan, but they give us what we need. They give us a way to say, hey, here's some data. I'm going to deal with that data. That data isn't here right now, but it might be here in a nanosecond. It might be here in a week. And either way, my code shouldn't sit here waiting for it to arrive. I want to ask for the data and then give back the thread on which I'm running my code to the system so that something else can be done while I wait for that data. And if the data should arrive and it arrives too quickly, I need some way to push back on that overwhelming torrent of data. So that's this idea of back pressure. All of these reactive principles were espoused in this very simple reactive stream specification, which gave us 4 foundational types. Now, this specification represented the sort of common ground efforts between the Spring team, then at Pivotal. We are now at VMware, and you'll see us as part of the Tanzu organization in VMware. And of course, it represented the efforts of the Netflix RxJava team. It represented the efforts of TypeSafe, now called Lightbend, and it represented the efforts of the Eclipse Foundation. So all these different teams got together, and we extracted out these common ground interfaces, and they gave us something on which we could then, assuming an ubiquitous component model, build software, right? And that's where Spring comes in. And if you've seen me talk about Spring and reactive programming in the last 3 years, then you know that it's ubiquitous. That's the whole point. Is I care about reactive programming. I care about this thing that sits at the root of my type system, and that I can use in my data tier, in my security, in my web tier, and so on. However, there are some wrinkles. When you start to look at reactive programming in the context of HTTP in particular, things get nuanced, to to say the least. HTTP, and by the way, for those of you wondering, there are no slides. We're just talking. If you don't see my screen moving, that's okay. Nothing's happening. I'm just talking to you because these are just words. The HTTP starts to get tedious. It gets nuanced. And the reason it gets nuanced is because when you think about what I want from a reactive system, I want to be able to connect to a service and ask for data, or I want to be able to connect and send data and not expect a response. I want to be able to connect to a service and have both sides communicate at leisure, at their own discretion. I want to be able to do all sorts of things that really you can't do with just regular request response HTTP. And so then you say, well, I can get around some of that by using WebSockets. And that's true as well. WebSockets give you bidirectional communication, kind of, and they give you asynchronicity, right? You can actually say, I'm going to ask for value, and that value may come like an hour later, right? That's fine. You don't have to keep a socket open for that to work. And so that's okay as well, but even there we have issues. WebSockets don't have headers. How do you propagate things like security tokens, right? If you're gonna work with Okta and you want to really leverage security, you're gonna have to do some extra work to kind of get around that, right? If you want to send tokens on the WebSocket frames, right? So that's not great. And HTTP is not great, especially HTTP 1.x, right? HTTP 1.x is textual, so it's porous, it's inefficient. HTTP 2, of course, is binary. And there's even been some attempts to sort of fix a lot of these mistakes, a lot of these sort of limitations in HTTP that were clearly, HTTP was very successfully designed to be an amazing technology with which to build a read-only network of documents. It's not so great for interactive, dynamic, volatile service topologies, right? Such as the ones that we're assuming we're trying to build in a microservices environment, in a cloud-native environment. And so somebody just tweeted gentle introduction to web services with Go, and the things I want to do in a microservices context and a dynamic microservices environment are going to be more dynamic, right? And so what I want is something that that gives me all that flexibility. Some organizations have made attempts to sort of satisfy these use cases. Google, in particular, they created gRPC on top of HTTP2. But even there, I find that that's not quite what I want because, first of all, it's asynchronous, but it's not natively reactive, right? That is to say, it doesn't understand this concept of back pressure. We'll talk about back pressure in a moment. It also requires Google protocol buffs, and code generation, both of which I find a bitter pill to swallow. Now, back pressure is this concept that I have one thing asking for or sending data to another thing, right? And the rate at which the thing gives me the data is the rate at which I consume it. And if that thing produces data too quickly, then I become overwhelmed. That's the problem, right? We don't in a service architecture where you have one node moving faster than the other, or indeed in any network at all, ever. Whenever you've got one computer able to transmit data faster than the other one can process it, then you run the risk of having flow control issues. And so flow control is basically, designing the system so that if one side should go too slow or too quickly, you can do the right thing. In the Reactive APIs, we surface the ability to ask for more or less data as part of the API proper. It's called back pressure. And it gives us a way to say, hey, I want just 10 more records, okay? Or just 100 more records. And as soon as I've processed that, I can then request another chunk of records. This gives me a stable way to build services that don't get overwhelmed. This helps allows us to build more reliable services. So I want reactive back pressure. I want that on the wire. I want other message exchange patterns besides just request response. I want simple things like headers for security, right? And I want that in a binary and payload agnostic way that doesn't require code generation. Enter RSocket. Now, RSocket is a protocol that was developed by the engineering teams at Netflix, who then went to Facebook. Those people, those engineers, have worked on RSocket at Facebook, where it's being used in production at scale. And again, let me stress that again. The first user was Facebook, right? It wasn't like, oh, wouldn't this be nice? This wasn't a interesting idea in some committee somewhere. This was, hey, we're going to deploy it to the largest website on the planet. Make it work, right? This is going to support that scale. And in fact, not only does it have to support that scale, it has to do better than what we were already accustomed to, right? It's not like Facebook wasn't the biggest website on the planet before they introduced RSocket. The whole point is to make it so that it's more efficient. And it was built, it was born or forged in the fires of that particular production environment, and that is given, it's been widely embraced by a lot of organizations that understand how valuable having something like that in an arsenal could be. So the Spring team, we were some of the first. We're very keenly interested in this project, not least of which is because the protocol itself is natively reactive. It understands back pressure, and it's operations ready, and we'll talk about those kinds of features in a second. And also because the Java client for this protocol, because remember, it's a wire protocol. It's not an API, it's a wire protocol. The Java client for this wire protocol was built on top of the Spring team's Reactor module, right? So Reactor is our module that builds on top of the Reactive Stream specification. So, my friends, we have an interesting opportunity here. What we're going to do is we're going to build a service. I'm going to call it a service, and I'm going to use. Do I want to do this? I'm going to use 2.40 M2. No, you know what? I'll use 2.33 because I want this to go well. But that said, there are some amazing things that are happening in 2.40 M2. So let's just take a moment to talk about that. Let's say that I've got the reactive web support here, and I'm just going to use Java 8 just in case. And I'm going to call it, yeah.
I just want to mention that it looks like you're sharing your 34-inch monitor, right? It's pretty wide.
Yeah.
It's not a regular like 1080p recording, which is what we're doing. So I don't know if you can switch it to like 1920 by 1080, but if you can't, just bump the fonts up because it looks kind of grainy at this resolution.
What about that?
That's better.
Okay, let me see. That was the easy trick. Let's see if I can make the okay. What about that?
Still needs a little zoom in, just because you're so wide.
Did I lose you?
No, you're still good.
Can you see it?
Yeah, it just needs, you got to bump the fonts a little.
Okay, hold on. I switched the resolution on the screen. Doesn't that work? Hold on.
Right, but the problem is you're still like the way wide one. Right?
The aspect ratio is wrong. Yeah.
Yeah.
Okay, hold on. Let's see. But I was wondering if it was if by moving to a different resolution, we would also make it easier for you to get more of the picture. So okay, scaled.
You actually, I don't think you can do the 1920 by 1080. I had to download other software to do that, but you know, just be aware that you might have to bump the font.
No, that's not it. You want 16 by 9, right? So
no, I'm saying that like they're not going to let you do it because they expect you to have 34 by whatever instead of, you know, what happens on mine because I have a 38-inch is I get black lines on the right and the left because it squishes it in.
No,
so you need other software for that. So just continue. Just remember to bump the fonts, and if they aren't bumped, I'll come in and yell at you.
Okay, I'll bump fonts. Are you there?
Yep.
Did I lose you?
No, you're good.
Marco?
Okay. Continue. Go ahead.
Oh, there you go. Okay. All right. Okay, can you see that?
Yep.
All righty. Sorry about that. Okay, so we've got a reactive web application, and I'm just going to demonstrate a few things that I love about Spring Boot 2.40 M2. Okay, so I'm going to just generate a new service here. And Spring Boot, the latest 2.3 release, is chock full of interesting features. Can you see that font? Let me make that huge. There we go. And hit generate. Okay, good. Oh. Alrighty, so give me a second here. I'll load this documentation. Okay, so the first thing that I want to show you is that I've got this new project. Let me open this up in my IDE. I'll make the font huge again. Give me a second. Can you see that font? I hope. Good. So what I'm going to do is I'm going to build a REST controller. Class greetings REST controller. And it's just going to be a simple get mapping. greetings. Okay, string hello world. Yep. Okay, and hello world. So there's that, and that's my simple controller. I want to have a little bean here that gets called when the application starts up. Public void start. Hello world. There we go. Okay, so I'm just simple bean, simple thing. All I want to do now is I want to turn this into a Docker image. And now with Spring Boot, that's pretty trivial, right? I have something called I have the Paketo build pack support, basically. So I can say Maven Spring -boot :build -image, and just sit back and wait a second. And what that's going to do is it's going to use this thing called a build pack, which was pioneered by Heroku and then improved upon by the pivotal Cloud Foundry team, and it's now a standard in the Cloud Native Computing Foundation. And it's this idea that we have Paketo rather is a thing at the Cloud Native Computing Foundation that supports build packs, and it's this idea that I'm going to give my my platform a arbitrary artifact, in this case a .jar, and I'm going to have this thing called a build pack evaluate what's in that artifact and then turn it into a container. And so that's what I'm doing here. I'm turning this into a container, and it's just done for me automatically based on the kind of artifact I've got. And so I don't have to worry for each of my organization's teams how we reinvent the recipe for deploying a Java application into a container, right? Because really it's a known quantity and we shouldn't be spending a lot of cycles on this. It just should be cookie cutter simple, right? So build packs give you that consistency. Now I have Docker images. What did I call this? I called it service. For some reason, is that what it is I just did? Basics service. This looks like it, right? 40 years ago for some reason, clearly not. So I'll say Docker run this. Okay, starting the application. There's my hello world and so on. So you get easy Docker containers with Spring Boot's built-in support now, right? I like that. Another thing I quite like is the ability that we're still working on. It's not yet GA, it's not yet finished, but it's really quite compelling, is our support for building native images. And so the way this works is use a third-party project called Spring GraalVM. It's not a third-party, it's our project, but it's experimental. And you need to add a few things. You need to change a few things to make it work. And so I'll show you how to do it here with the native image plugin. Okay. Maven plugin. So you got to make sure you're using GraalVM, right? I think I am. Let me check. Java version. Switch there. You know what? I'm having a weird day. Besides the red orange sky, I also am. I've had a brief dalliance with a mechanical keyboard today called a Keychron version 2, and it's awesome, but it's a different layout. So now I'm back on my regular clickety clackety chiclet, keyboard, and my my rhythm's all off. Okay, so got this. Got to add this Maven plugin. It's not great. I'm going to give you that, but it is boilerplate, so you can just copy and paste with one exception. So you go back to your build. Here we are, right to the bottom. And the only bit that you need to customize for so many of the applications I've looked at thus far is this bit, right? So service application, copy reference, paste. Okay, that's good. And I've got to use 2.40 M2. That's what I've already done. I'm using 2.40 M2. So there it is. Okay, 2.40 M2. And finally, I need to add the actual dependency to the Maven plugin. To the Spring GraalVM dependency to the build. So I just add that as per normal and re-import. And then finally, in your Java code, you need to tell Spring to not create cdlib proxies. So you have to just use regular proxies. And so we say proxy bean methods equals false. And with that, I can now go to my command line and do a Maven -p native. That's what I've done back in the build here. I activated a profile or added a profile called native. And I'll say Maven clean package. Okay. Now what this is going to do is it's going to run the GraalVM native image builder. This is an ahead of time compiler, and the ahead of time compiler is kind of like basically it's just a native compiler. I don't know why we give these confusing terms. Think about what we did. Most people before Java had native compilation. So they wrote code and then they compiled it to native binary code. And then in Java we had this, we had bytecode. So there's a bit of an indirection between what you've typed in your source code and what gets run, right? That bytecode gets interpreted and you get a program. Eventually, we had a JIT, right? That's like Java 1.1. The just-in-time compiler looked at the executing interpreted code and says, hey, this is running fast enough, running frequently enough that we can compile it to native code on the fly, and that native code will then run much faster. And so this thing is a well-known aspect of using Java. Large organizations like Google, before they deploy a service into production and actually turn it on, they'll actually warm up the JVM. They'll exercise code paths that they want to be JITted so that they compile and run in native code performances. Well, eventually, this GraalVM project, it's a Java implementation of a just-in-time compiler, but they also realized, hey, wouldn't it be cool if we took this thing that makes individual segments of our code fast? Wouldn't it be cool if we just made it so that it applied to everything? And so we're calling that ahead-of-time compilation, which is to say that they're just compiling stuff. It's only in Java that we have to say that the just-in-time compiler is different because it's now just a regular compiler, so it's a ahead-of-time compiler. 2020, I don't know. Anyway, we have now a native image, and so I go to my build target and cd target, and you've got the jar, right? The jar here is service 19 megs. That's fine, and you know how to run that java minus jar whatever service, and that's just fine. But it implies a JVM, right? So that's fine. I like that. But I want to run the native image, and the native image is this bit here, com example service application. It's 44 megs. It has a runtime. It's not the JVM, mind you. This is no longer a JVM application. This is a native application that has some approximation of a garbage collector and so on, but it's certainly not Java. In fact, this isn't portable. It's only going to run on the Mac or on Linux or on whatever platform to which I've compiled that code. Now, once I've compiled it, I can run it, and boom, right? So there's the slow version of the application. 0.062, so that's not 0.6, that's 0.062, so that's it's 0.6 of 1/10 of a second, right? Really, really quick. So let's see if I can get it to go faster. You saw that there's a bit of a delay there. There you go, oh no, it's about the same, isn't it, I guess. Oh well, perception is everything. So 0.62, localhost 8080, and what did I say, greetings? There you go. Hello world, indeed. So you can do a lot more interesting things on this. Obviously, there's a number of supported examples that you can refer to in the samples directory where they look at reactive web applications, R2DBC applications for SQL-based data access, reactive and non-reactive MongoDB. I mean, all sorts of stuff, right? So I encourage you to check it out. None of that is particularly germane to what we're going to talk about today, but I just wanted you to know there's some really interesting stuff. And I'm using 2.40 M2, which is a better fit for the latest and greatest versions of the Spring Graal native support. But that said, the Docker support was there in Spring Boot 2.3, which is now GA and already into service releases or maintenance releases. Okie dokie. So RMR target. I've got this code base. Actually, let's just get rid of all of this. We don't need any of it. Goodbye. Go back here. Goodbye to that. And we're going to build a service this time, but we're not going to use the reactive HTTP web support. No. We're going to use RSocket. We're going to use Lombok. We're going to use Spring Security. You're going to use the, do I need anything else? I don't think I do, actually. RSocket, Lombok, Spring Security. Feels like that ought to be enough. And now I'm sure that I'm missing something. I just don't, for the life of me, know what. So that'll be fine. Let's go ahead and hit generate. And that'll give us a new project that I can then open up in my IDE. There you are. UAO service.zip. Oh, did I forget to tell IntelliJ that I killed the project? Okay, IntelliJ is not happy with me. That's all that. All right, take 3. Go gadget web. Come on. There we go. Do I have an orange hue from the orange sky. It looked like Blade Runner. It was bizarre, very dystopian. Okay, so service, application, and application is just going to be a RSocket service. Now, when we build this RSocket service, I could talk to a database. I could talk to anything that produces reactive data. But for our purposes, I don't want to. I want to assume that you've got some sense of how to talk to a SQL or NoSQL data store using Spring data, and that you've got some sense of how to build HTTP endpoints using Spring Web Flux, and so on. So what we're going to focus on is really RSocket. And so I need a strawman API, a strawman service, or a straw person service. And so I'll build a greetings service. And this is just going to be a greeting service that returns a reactive stream of greetings response given a greetings request, okay? And the response is going to be a message that gets sent back to the client, or the thing that's asking for the data anyway, given a parameter, which is a name, right? So the request will have a name. Whoa, easy there. What was that? Data, RX constructor, no RX constructor. Okay, good. So there's my my two different types, and this will be a service. And here, I'm going to return a greetings response, a stream of greetings responses given a greetings request. Now, this is a specialization. This type here is called a flux. A flux comes from Project Reactor. Reactor is like I said, it's a project from the Spring team that builds on top of the Reactive Streams foundations. It gives us, along with its peer object called a mono, it gives us several types that we can use, several operators that we can use. All right, that's fair. It gives us several different operators that we can use to build and to handle sort of scatter-gather kinds of compositions and integrations. So a flux is a reactive stream. It's a publisher, ultimately. A publisher comes from the reactive stream specification. Publishers publish data to subscribers. Subscribers can then consume the data. When they first connect to the publisher, they're given a subscription. We'll come back to that. When the data arrives for the subscriber to process, it arrives in the onNext method. Should there be errors, when there are ineluctably errors, that happens in the onError method. And when you're done processing the data, that happens in the onComplete method. Now, the subscription is arguably the most important bit here, right? This is where the subscriber, subscriber is given a reference or a pointer to the subscription, with which it can then later on slow down or increase the speed at which it consumes data by either requesting more or less data, or just stopping the stream altogether by canceling it, right? So this is very important. This is what we call back pressure. This is the ability of the subscriber to say, I want 10 more records and no more, thank you. With these types and specializations like Flux, which give you, which describe a stream of potentially infinite capacity, so 0, 1, 2, 5, a billion, trillion, infinite, whatever, right? We have tools with which we can build sort of reactive services. There's a parallel type or peer type or a sister type called a mono, and a mono is a publisher. It's also a publisher. It has a lot of the same operators and a lot of the same capabilities as the Flux, but a mono only handles at most one record, so it's 0 or 1. So mono or Flux, all right? Now, these types are very, very, they're useful. You're going to see them all over the place. So I hope you've got some familiarity with them. And what we want to do is we want to return an infinite stream of data, right? Just a thing that's going to produce data. Because one of the use cases for reactive programming where it really shines, where it really comes into its own, is in these use cases where you have a risk of monopolizing a thread, where you might otherwise unduly monopolize a thread. So anything that requires immediacy of responses will monopolize a thread, right? Think about that, like a stock ticker. You're going to keep a client connected to a service, and they're going to just constantly be speaking to each other all the time, communicating the changes in the stock, right? Because that every little last millisecond or nanosecond could be, in concrete terms, a lot of money, right? So it becomes very important that you have immediacy of the results. So this is one example of where you want that, right? Let's see, here we go. And what I want to do is I want to have an example where I'm getting immediate results, where I'm able to, if I want to, get any kind of updates as fast as they arrive, but I don't want to keep that thread open, right? And this is where Reactive APIs really come into their own, because they give you a way to pump out results, but then jump off of the thread and handle something else in the system. So you can see, in this case, I've got a reactive stream that I'm adapting from a Java 8 stream. And I'm introducing artificial time, so you can kind of see that, yeah, every second, like clockwork, this thread is going to wake up again, and it'll produce a response immediately, right? But this is just an arbitrary thing. I'm just demonstrating that we have this asynchronous stream of data, and yet I can create a lot of these. I can have a lot of these, and I'm not going to lose the scalability that I would if I were to write this kind of code manually without a reactive API, where I might need to keep a thread assigned to the pump where I'm producing these greeting response objects, right? Because in that scenario, if I had one thread per client, I would only be able to scale to as many threads as I can reasonably handle on the JVM, which I'm sure any of you will know, it's not that much. It's not that many, right? These operators, like these types, publishers and Flux and Mono in particular, they give you a lot of things that you can use to also handle errors gracefully, to do things like retries, to do on-error resume, so that if there's an exception, you can control how the stream should gracefully degrade and so on. So there's a lot of benefit above and beyond the simple operators that we've just seen here. Now, I've got a greeting service, and what I want to do is I want to just create an RSocket endpoint. Okay, so we'll just create an RSocket controller, class greetings, RSocket controller. Okay, and here I'm going to create an endpoint that lives at /greetings, not /, just greetings. And it's going to return a stream of greetings response, greet, and I'll take the greetings request, right? So I'm adapting this. And in order to do the work that I want to do, I need that greetings service. I'll just inject that here, and I'll inject the argument into the constructor, and I'll say this.service.greet, passing in the request. Okay, so I'm just passing through to my local service, my little greeting service thing here, and that's already most of what we need to do to get a simple, working, albeit trivial, RSocket service up and running. The last thing that we need, though, is a port. So you need to be sure to specify a port. And this is, I think, a little asymmetrical, and it's a little frustrating. It's, you wouldn't, I can't be the only one who tosses and turns at night, wondering why things are so asymmetrical in life sometimes. So here, when I have the RSocket server port, that actually turns on the RSocket service, basically. It tells Spring Boot, hey, there's somebody interested in creating an RSocket endpoint to which something else in the world could eventually connect. Whereas if you have Spring Boot start a web or web flux on the class path, then it implicitly will create that service, and it'll default it to, as you all know, port 8080. So I think I prefer having to opt out of having the implicit service with RSocket, whereas in this case I have to opt in. But they will say that the reason you have to opt in is because there's nothing about RSocket that says it has to be a service. There's no reason it couldn't be a client. Indeed, it might very well be a client for the majority of the applications that people are building these days. And this is more true when you consider that RSocket doesn't have a traditional notion of a client or service. Indeed, when you have a thing that produces a response, that's called a responder. And when you have something that's requesting a response, that's called a requester. But either side may switch to either role at any time, or indeed at the same time, right? Both sides might be doing both things, requesting and sending data. So it gets a little fuzzy. Then the semantics are interesting. For our purposes, just to keep things clear and to kind of understand where I'm positioning things relative to other things in our application, we're going to call this the service, even though this is technically the responder. And we're going to call the thing that asks this thing for data, we're going to call that a client. And actually, we're going to create two different clients. We're going to see 3 clients in action. We're going to create 2 of those. So they're going to act in the traditional role of, hey, I need data from this thing that I know can give me the data. Okay. So let's run this application. Oh, we're not. There you go. Good. Hey Matt, do you ever have that issue where when you drive a screencast from your monitor, it causes the fans to burst into flames? And
oh yeah, if you use like Camtasia, it can get real bad.
You what? Oh, you have to use a different.
Yeah.
I tweeted yesterday that you know that Skittle that you use to cook an egg, I could cook that Skittle on my CPU after a long enough screencasting session. So it gets insane. It's just, I don't know how this wasn't a thing. Now, of course, granted, this is a 5K monitor, so I can, that wouldn't be easy even with the best of cards. But nonetheless, you would think this would be like a higher priority. I don't know. It feels like video is one of those things for which Apple devices are supposed to be great, But hey, at least we have a keyboard. That's nice. Keyboards are nice. Okay, so I'm going to take out Spring Security just for the moment. Don't cry, Matt. And put this right here. Restart. Go. And the thing I did wrong was I had security in there, and we're not ready to use Spring Security, so it's going to lock down the endpoint, which I don't really want. Okay, so now it's up and running again, and we're going to use this very convenient utility from my buddy Toshiaki Maki called RSC. Okay, so Maki RSC, and this project is an open source GitHub project. It's a CLI for RSocket that aims to be a curl for RSocket, and it's just dope. It's extra dope, right? It's really, really cool. So you specify first of all the port on which you want to make the request, or to which you want to make the request. So RSC TCP : localhost 8888. Okay, let me see. And I want to send it to the greetings endpoint. That's the route. And the date, and then the type of data I want is a stream. So I'll say stream, and I'm going to send some data in, very much like curl. And so I'm going to use the content negotiation that we have here. Let's see, like this. Alrighty. All right. Okay, so that'll be a name and Matt. Connection refused. Localhost. 4.8. Thank you. Okay, so there's my infinite stream of responses coming from my RSocket service. Yeah, and if I wanted to see the details, I could actually log the RSocket interactions. Right, this is an RSocket client after all. So on subscribe, on next, you can see the control flow. You can see what's happening behind the scenes with the Reactive API. So we're seeing on subscribe, we're getting a subscription. We're requesting an unbounded amount of data, which is like -1. And then we're just processing the data as it arrives every second. And you can see what's happening here. It says, hello, Matt, blah, 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 at a certain time zone. I can go a step further with --debug. Okay. And that'll actually give me the binary data, right? I can actually see the hex dump of all the data, which is cool. If you wanted to do a Hollywood movie where you pretend to be a hacker or something. Okay, so very, very convenient client, but you're not going to deploy this. You're not going to like shell out to the RSC client from your Java code. You're going to want to talk to it directly. So that's what we're going to do. We're going to build a client. Okay, so client, and I think we can just use the same things there. So I'll hit generate again. UAO client.zip. Alrighty. So now, here, what I want to do is I want to build an application that talks to the service. And in order to talk to it, I need to connect to it. And I do this with an RSocketRequester. Now, an RSocketRequester is the reactive client that you use to talk to an RSocket endpoint. It gets created but once. What is going on with my... I typed that 3 different times. What is happening? Every time I type in curly bracket, I get that business. Okay. What is happening? Oh, Canadian French. Sorry. Oh, that's awkward. Okay, so again, did I mention I was screwing with keyboards earlier. Au revoir, mon ami. Okay, so build. I'm going to connect to the host and port. So connect TCP. It's deprecated. That's nice. Localhost 8888 block. So what I'm doing is I'm connecting to the host and port, and I'm doing this at startup time. When the application starts up, I'm actually connecting to the service, and I'm staying connected, right, for the life of the application. And the reason I do this is because RSocket connections are stateful. You create one RSocket connection for each host and port to which you want to connect, and then you stay connected for the life of the application, and you can send as many transactions, as many in-flight individual requests through that one socket as you want. This saves a considerable amount of time and the constant network connection and ACK and all that stuff. I don't have to do any of that for each request. You're already connected. So things like the handshake, you can also do that just once at the startup time as well for the security if you want, or you can do it for each transaction, right? And you can also repurpose the same requester for multiple users, right? So it doesn't have to be each RSocketRequester gets their own, each user gets their own RSocketRequester. You can send a request to the endpoint and then authenticate, uniquely for each in-flight transaction. But the point is, you have that choice, okay? So now I've got RSocketRequester, and what I want to do is create an application listener. So it's an application listener that listens for an application-ready event, and this is going to be the RSocketRequester listener. Alrighty. Return event. Good. And I'm going to inject the RSocketRequester that we just created and use that to make a call to the downstream service. So route greetings and data. The data I'm going to send in is going to be the greetings request that I created over here. So I'm going to copy and paste these DTOs. Paste that there. And we're going to say new greetings request jug, and I'll retrieve a response.
Can you bump the fonts a little?
Yep.
Thanks.
Okay. There you go. How about that?
Looks good.
It's okay. Sorry.
Yep.
Thanks. And then I'll subscribe. So I'm going to log out the results here as they arrive. Now this is a client, and it's asynchronous, right? So this asynchronous subscribe can happen in a separate thread at a separate point in time. And indeed, we know it could happen out. At least there could be a delay between the initial request and at least 1 second of, or at most 1 second of delay between the first actual result we see. So what's going to happen is the client will start up. It's not an RSocket service, so there's nothing keeping it blocking a port, and so it'll just shut down immediately. So you need to do some trickery here sometimes. Like this, you need to say stop system.in.read to keep the process running, right? So that's what I'm doing. I'm just creating an RSocketRequester, and I'm going to run. Here we go. Alrighty, so you can see there in the console, maybe if the font gets a little bit bigger. There you go. Whoop. Easy there, Charlie. Okay, there you go. You can see each response is coming back, right? It's a greeting response, message equals hello, whatever, blah, blah, blah. Okay, so it's producing a new value every second in perpetuity, and it's going to keep doing that forever, right? And that's okay, because again, in between the raindrops, that thread is not being kept open to produce this response. Now, this is a low-level client. I just used the RSocketRequester. It wasn't so bad. I specified the route, specified the data that I want to send in, specify what kind of data I expect back. I expect a multi-valued stream of responses back. I could say I want a single value, in which case I'd say a mono, right? In this case, I would have a request response kind of stream. What I'm describing here is what's called a stream, right? Dash that stream in the RC client, which is to say I send a single value in, I get multiple values back. I could say that I expect a mono of empty, in which case it's fire and forget, right? I'm sending data in, but but I'm completely disengaging from the machinery required to get a response or even expect a response. I disconnect, and so the service can use that signal that we send when we make the request to say, oh, okay, I'm not even going to bother producing a response. Don't bother keeping the thread open. So that can be valuable as well. That can save you a lot of time if you have something for which you don't need a response. Maybe it's just a fire and forget status notification change, or if you're awake and you see it, great. If you don't, who cares? It's just telemetry information, that kind of stuff. Okay, so now I've got a client. I'm using a low-level RSocketRequester. It wasn't that bad, like I say, but I think we can do better. So one option that I'm a little proud of, if you'll indulge me here, is something called Spring RetroSocket. Now, this is a project that I built, basically, and it's an experimental project on the Spring Project's experimental thing, in the same place as the Spring Graalvm native thing is experimental. And it's meant to be a declarative retrofit or feign-like RSocket client, and it was inspired by a discussion with my buddy Mario Gray. Now, this documentation has most of what we need to get this working. So what you need to do is add the RetroSocket dependency to your build. .xml. Okay, you need to specify the version, in this case 0.01 snapshot. If that's not confidence inspiring, I don't know what is. And you need to make sure you have the snapshot or milestone dependencies, which I'll do that. I'll just do that here. I've already got it, actually. Look at that, milestones and snapshots. And then you can just create a declarative RSocket client. So I go back here, and I'll go down to the very bottom of the screen, and I'll create an interface. Interface, greeting client, message mapping, greetings, publisher of greeting response, and given a greetings request. So this looks pretty similar to the signature on the server side. And in theory, for a simple enough signature, you could actually use the same interface. You could actually, you can have typed services if you wanted, kind of. Okay, so I want this to be an RSocket client, and I want to enable RSocket clients. So I'll say enable RSocket clients, and that's it. That's the entire thing to get that to work. So now we can write a new application listener. Application ready event RetroSocket listener and greeting client. All right, return the event. Alrighty, so client dot greet new greetings request. Doug and friends. And this part, I want to subscribe, of course, because what I get back is still a stream. Okay. There you go. Okay, so this is my stream, and I'm gonna, actually I can get rid of that. There we go. So there's the same call. I just don't have to worry about defining the actual low-level stuff, right? And this interface, I can do things like declaratively define headers. I can do things like communicate message destination variables. So this message mapping URL can actually have the equivalent of like a path variable in there. You can also send that. So there's a lot of flexibility there, and you can encode all the common exchange patterns from the perspective of a client, right? So from the perspective of a client, you can do that. However, one of the most powerful parts of RSocket is that you don't always have to be a client, right? So let's bring back this old version and remove RetroSocket, as it'll take us no further. And so what we're going to do, what I want to look at now is the possibility that, first of all, there's other ways to consume RSocket endpoints, right? So we've looked at RetroSocket, we've looked at the RSocketRequester. What I want to do now is I want to look at Spring integration. Now, Spring integration is a pipes and filters messaging framework, and it's an old framework in the Spring ecosystem. It's been around since 2007, and it's personally one of the main reasons I decided to raise my hand and start contributing bugs to the source code in the Spring ecosystem. Before that, there were much fewer bugs. Okay, before Spring integration and before my interest in contributing to the code bases, much fewer bugs. But I'm number one, more bugs per line of code than any other engineer on the Spring team. So there's that, right? So in 2007, I was like, oh, this is super cool. And Spring integration is a pipes and filters messaging framework. So it's asynchronous by default. It assumes that you're going to have pipelines full of data flow, where one component processes the data, then sends the message to another component, which processes the data, which sends it to another component, and so on. Messages arrive in an integration flow thanks to something called an inbound adapter. Inbound adapters are things that originate messages or source them from the outside world, where they are, of course, real things. They could be a new tweet that somebody tweets out, or a new TCP or UDP message for a packet or frame or whatever. It could be a new message in Kafka. It could be a new file appearing on a local file system service or a remote mount like FTP or SFTP or FTPS. It could be a new email arriving. It could be anything, right? Anything that could be an event or a message or whatever in the real world. You write or use an adapter to turn that external thing into a message in Spring Framework, right? A Spring Framework message type. And Spring Framework gives you this very nice type called a message, which has an envelope, which has payload and headers about it. And that envelope, that envelope is very, it's very natural. If you've ever used any kind of messaging technology, be it Kafka, RabbitMQ, or JMS, or whatever, then you've probably seen something like this. So it made a lot of sense to have that abstraction in Spring Framework itself. Now, Spring fact here, that message type originated in Spring integration. It was then put into Spring Framework. So it's actually a messaging thing in Spring integration first, and then we decided to make it a general purpose thing, and so on. So now, once you've originated a message or sourced it from an inbound adapter, you can process it, do whatever you want with it, split it, route it, aggregate it, enrich it, transform it, etc. And then you can send it out using an outbound adapter. So you can take a Spring Framework message and send it out to the real world. And that could be you write to a database, or you send it to an FTP server, or you send an email, or you write to you invoke an HTTP endpoint or whatever. That's a very common flow. Sometimes, however, you have a more conversational flow where a message comes in and the message gets bounced along from one component to another, and then eventually you want to send it out, but then get a response, right? So it's actually kind of a request response scenario, or the other way around, right? The other way around is the integration flow receives a message and then sends the reply, right? So in the case where the integration flow has a message and it makes a request of something else in the world and it gets the response, that's called an outbound gateway. In the scenario where the integration flow is the thing producing the response to the request coming from the outside world, then it's an inbound gateway. So you've got inbound adapters and inbound gateways. You've got outbound adapters and outbound gateways. And these are the things that connect us to the outside world. Well, there's actually an RSocket gateway, and we can use that. So let's do that here. We're going to use integration. We're going to use Lombok. We're going to use integration. And we're going to use RSocket. And I'll hit generate. Whoa. Okay. UAO integration.zip. And we're going to create a simple Spring integration flow that uses some of the built-in adapters that come in Spring integration itself. So I'm going to bring in the Spring integration RSocket support. Integration. Not Azure, thank you. Want RSocket. And I want also a the file adapter, so I can just perceive messages or events as they occur on a file system. Okay. Now, if you look at the author tags for a lot of the file stuff and the feed stuff and the old Twitter stuff and whatever, you'll see my name's all over it. So I'm very comfortable. Not all over it. Nowadays, it's been more than a decade. It's been a decade at least since the Spring team began the process of erasing or expunging or refactoring my atrocities out of the code base. So it's much better now. You can actually use it in production. I wouldn't say the same was true 10 years ago. Now, we have an integration application. Let me make the font massive. And this integration application, again, all Spring integration applications center around an integration flow. So RSocket integration flow. And let me import that. Good. So what I'm going to do is I'm going to build a flow that originates or sources the message flows.from a file inbound adapter. So basically, whenever a new file appears in a directory, I want to know about it. Okay, so I'm going to say files, files.inbound adapter. And here I need to specify a file. So I'll say new file. And the file, how can I build this file? I'm going to look at the desktop, right? So I'll say value user, nope, there you go, user at home, desktop in. Okay, so that's a bit of an expression. I'm just creating a file there. File, okay, and I need this to be an actual resource. Good. Alrighty, so now I'm going to say, given that directory, I want to create it if it doesn't exist. And this creates an inbound channel adapter spec, and I want to use that from here. So I can say from there. Now the problem is that that file system doesn't really have a way to tell me if something has happened, if there's a new file available. So I need to create some poller. I need to create a poller, configure a poller. Now in Spring integration, pollers are just scheduled polls, right? You poll a data source to see if there's new data available. So the way we compute whether there's new data available is we scan the file system on an interval or at an interval, and we see if there's anything there that wasn't there in the last pass, right? Very simple trick. Now, some mechanisms, some inbound adapters don't require a poller because they can tell you when something has happened. So for example, Kafka. You don't need to poll Kafka. I mean, you could, but you don't really need to, right? There's an API that you can use to say, hey, as soon as something has happened, let me know. And then the Spring integration inbound adapter automatically invokes your downstream code whenever that happens, right? But here, we need to configure a poller. So what I'll do is I'll say poller metadata, em.fixedRate. And here I'm just going to poll every second, okay? So the data is going to come from that. And this is kind of nice, by the way, the fact that we've decoupled the inbound channel adapter from the frequency of the read from that directory, right? So from that inbound channel adapter, I then want to turn the file that I get into something. So again, I could just do a new handle. I could say new handle. And when I do this, I have to say that the handler is a component that's going to handle the output of this component. So the input type of this component and all the other ones, right? Like, I have to worry about that here, right? These are all different operators, and I can do all sorts of things with the data that gets passed into each one of these. But it's a pipeline. Data flows out from one thing and into the other. And so in this case, the output of the input of the inbound channel adapter is a file object. So I have a file here, new file in the directory, right? And this code will only execute when there's something to process, right? New file, right? So that's very nice. Spring integration let me declaratively listen to things, and I can kind of insert myself into the flow just by adding a .handle. Now, what I want to do is actually transform the data that I've got. So I want to transform the file into the string payload. And of course, there's, it's not hard to create a generic transformer, right? Like generic transformer file to string, right? I can do that. But why? Just let the framework do it for me. There's a lot of Legos that come out of the box, so I can just use that there. And what I want to do then from there is take the string and transform that into a greetings request. So I'll say new greetings request, but of course I don't have a greetings request on the class path. So let's go back to window, service, take that, take this, paste this here. So these are my DTOs. I'm just using them here. Greetings request. And I'm going to assume that there might be a new line, so I'll strip the string there. Okay. All right. Or you know what? We can actually do that upstream. That way, it's always going to be correct. So string dot strip. This is the nice thing, is that if I had written trim, where did strip come in there? That's a new thing. I don't know if that would have worked. So the nice thing about this is I can write these sort of Lego brick bits of functionality, and I can reuse them later on, because as long as the precondition is met for the kind of message that I'm going to get, then who cares, right? I can always adapt the output of one thing to another thing before I send it into yet another thing. This makes it so I can easily test these things as well. In this case, I'm just calling constructors and using method references, but the point is it's very easy to unit test these things in isolation because you have a very strict sense of what's expected and where. So all I'm doing is I'm taking the file, turning it into a string, taking the string, getting rid of the extra new line just in case because it's a file, and then turning that string into a greetings request. And what I want to do from there is I want to actually call the RSocket gateway. And to do that, I'm going to create an RSocket outbound gateway. And the outbound gateway is going to invoke the greetings endpoint, and it's going to expect a response of type greetings response.class, and the interaction model is going to be a request stream. So I've talked about that. I've alluded to that a little bit so far, but basically we need to tell RSocket what kind of interaction this is. Am I expecting a single value back, multiple values back, fire and forget, or bidirectional stream in, stream out, in which case it's called channel. So request stream is what we're doing. We're sending a single value in and getting a stream of responses back. And the final thing that I need to specify here is a client RSocket connector. Now this is just a bean that tells my Spring integration code how to, client RSocket connector, it's telling my Spring integration code how to connect. Client RSocket connector. Okay. And in this case, there's nothing fancy about it. It's just a host import, so we know what to do there. Okay, good. I'll inject this into the client RSocket connector. Good. So this is the RSocket outbound gateway spec. Mouthful, but it works. So transform this handle. I'm going to send it out to the RSocket's gateway. Okay, and then finally, when the response comes back, I'm going to get a stream, a flux of greetings responses, right? And so, what if I wrote a handle message, a handle thing, the correct handler would be a flux of greeting response, because after all, the response from the gateway is a flux of greeting response. That's the object that gets produced from the gateway. But I don't actually want the flux. I want the greetings responses. I want a never-ending stream of greetings responses. And so what I'm going to do is I'm going to split it, right? So I'm going to say dot split. Now split in Spring integration knows about reactive types now. So that's one of the new things in the last year or two, is that we've taught Spring integration what to do in the face of a reactive stream like a flux or a mono and so on. So it'll do the right thing. However, we now run into another issue, which is the downstream components have no way to push back. There's no way for them to communicate back pressure because Spring integration isn't specific to Reactive APIs. So what we want to do is to have a component that is back pressure aware. So I'll introduce a Spring integration message channel. And this is going to be a named type, right? It's a named conduit. It's a pipe through which data will flow. It's like a channel by default. And, you know, it's a thing that you see if you study integration patterns, right? If you look at the seminal tome by Gregor Hoppe and Bobby Wolf, there's this amazing book called Enterprise Integration Patterns. And the book talks about a number of different patterns, and one of them is a channel. A channel is meant to be the explicit, the queue, the connective tissue between components in a pipeline. In this case, you can think of it as having a channel implicitly from transform to transform. There's a channel. We're just making it explicit here because we want to control the default kind of channel. And so the data is going to come from the split. It's going to be it's going to be a reactive stream of responses that'll be emitted to the next thing, which is the channel. The channel is now back pressure aware. It's both a subscriber and a message channel. And then finally, we're going to be able to handle the data. And so what I want to do is here, I want to handle just the greetings response. I won't get a flux. I'll get individual records from the flux, right? That's the benefit of the split there. And so here I can actually log the results out. So I'll say system out new greeting payload dot to string, replace with lambda, and voila. Okay, that's the RSocket Client. Let's run this. Okie doke. There we go. So we don't have anything happening here yet because there's no file. Remember, the whole pipeline gets kicked off the moment we have a file in the directory. So it's in desktop. It's my user directory /in. Right, there it is. There's that. I'll move. I have to have some text in there, don't I? So desktop in echo djug spring fans hello one. Okay. Oops. What did I do wrong there? No decoder. Greetings response. What just happened? No decoder. Well, if you got the greetings response, why do we? I feel like you're already halfway there, Mr. Spring Integration. Don't have to be rude about it. Generic handler. Got the data there. Feels like that's half the battle. Oh my goodness. Okay. I need the RSocket. Oh my mouse is about to die. We are living in the worst timeline when your mouse can fail you. Okay, hold on. Lots of things going wrong for no reason. Don't worry, I have a USB-C cable just for these peripherals. Go gadget web. Okay, good. All right, so the way to fix this is to make sure that the RSocketRequester knows about our encoding strategies, and that means I have to plug in. That's so weird. I have to plug in the RSocket strategies object. So RSocket strategies, and sure would be nice if this already knew about that. RCRC, turn CRC, CRC.set RSocket strategies, and voila. Okay. Okay, run this again. Good stuff. Stop and restart. There we go. Every second in perpetuity, we're going to get that response back from the Spring integration flow. What I've just demonstrated to you is how to use Spring integration, which knows about everything, and it can integrate with all sorts of stuff. It's not limited to just reactive or non-reactive APIs, right? We've looked at how we can use Spring integration as an easy, convenient, and elegant way to integrate, messaging data, messaging flows that are not reactive per se, with reactive sources and sinks like RSocket. Okay, so now we've got 3 different clients that we've looked at so far, right? Or 4 actually, if you think about it. We go back to the client. We've got the RSocketRequester. We looked at RetroSocket. We looked at RSC, and we looked at Spring integration. We looked at 4 different ways to invoke the same RSocket service. Now, we've acted as a client this entire time, and I don't mind being a client, but one of the most powerful things, as I keep on harping on about, is that you can actually be bidirectional. You can actually have a client that is both a client and a service, right? And so this is where we get into some really interesting opportunities, is we can actually have the service ask the client for something. So imagine that my client could tell the service how healthy it is, right? It could give us a constant heartbeat stream of information that tells us how well the client is doing and whether the service should bother trying to give data to the client if the client is no longer able to process it, right? And this is a bit of a contrived example because in point of fact, there's actually a message frame in RSocket itself, but just bear with me. Maybe you've got some other information, telemetry that you want from the client that you've exposed as a stream from the client. So I'm going to go here in the client and I'm going to create a client health state. So class client health state. And this health state is going to have a Boolean healthy. Oops, healthy. And whenever somebody makes a call to this client, we're going to return a stream of health states. So hopefully that'll always return healthy equals true. So health controller here. Good. And we're going to create an endpoint. It's going to be called, unimaginatively enough, health. And it's just going to be, same thing. I'm going to do a client health state, health state flux, whatever. And I'll just return a never-ending stream of results. So stream.generate new supplier, new return. Oh, come on, do the thing, Josh. You can do this. You've got this. There we go. Client health state, and we're going to just do it's contrived, right? I'm just going to simulate actual entropy. So we're going to say it's healthy. So for 80% of the time, right? Effectively, it'll be healthy. Otherwise, it'll be sick. So I'll stagger out the results. So I'm going to send back a heartbeat every second for the consumer to work with. Okay. Now, what I want to do is I want to make sure that when somebody connects to the client, remember it's bidirectional. When they connect to the client, I want them to be able to ask the service for that information. Okay, so in the client code, what I want to do is I want to make sure that we actually configure the RSocketRequester that's being used to make the call to the service to also advertise the availability of these messaging endpoints. And so what I'm going to do here is I'm going to create a RSocket connector. So it's a bean socket connector. And this socket connector, I'm going to build by saying RSocket message handler dot responder. In order to do this, I'll need these RSocket strategies, and I'll need my client health state controller, right? My endpoint. So strategies and controller. And with this, sorry, not connector, it's an acceptor, totally different. With this, I can now customize the actual building of the RSocketRequester itself. Paste that in. And here I'll say that the RSocketRequester is this, so it's connector, socket connector dot acceptor, socket acceptor. Okay. SC. Sorry. SC. Okay. So this is my RSocketRequester, and that's basically it. That's all I need to do to make that work on the service, on the client side rather. Now let's go change our service so that it does the right thing there, right? So where's our service? Here's the service. Okay, and in the service code, when somebody connects to the controller, to the greetings endpoint, we want to ask Spring to give us a reference to the incoming requests RSocketRequester. So the socket represented by the incoming, the client, the incoming requester, the thing that's asking for the data. Okay, so incoming requester. There you go. And with that, we can say incoming requester dot route health. I'm going to go take that client health state object back and see. Come on, this is integration. That's client client service. I'm going to go back to the service. I'm going to copy the DTO from the client to the service this time, the client health state. And here I'm going to say, okay, route, and the data that I'm sending in is nothing, basically, right? I don't actually care what I send into it. And mono.empty. And finally, when I get the data that comes from it, I want the client health state.class. Okay, so that gives me a stream of client health state from the incoming RSocket request. And now I've got this stream from my service as well. Okay. And what I want to do is I want to keep streaming these greeting responses, but only so long as this health state is true, right? So I'm going to say I want to filter CHS, each instance. I want to say if it's healthy. If it's not healthy, then I want to keep it. If it is healthy, then I'm going to discard it. And so what will happen is eventually this reactive stream of responses will be, ideally, knock on wood, if everything goes to plan, this will be forever empty. There'll be nothing in there, right? Because we'll hopefully, even though we're getting health updates every second, we're discarding all the ones that are not, we're discarding all the ones that are healthy, because we don't care about healthy, we care about not healthy. And so if there is anything in the stream, then that means that there's something that's not right. It's not healthy on the client, right? So we have a hopefully empty stream. The second it's not healthy, that's a problem, and we want to stop sending these greetings responses back. And so what I'm going to do is I'm going to say, send the stream of greetings until the client health state is not empty. Okay, so it's a very nice operator here. There's a lot of really nice operators that you get by using Reactive APIs that allow you to do service orchestration and composition and so on. And RSocket, of course, benefits from this, but so does HTTP. I mean, just the fact that Reactive APIs make service orchestration and composition so much easier it's hard to overstate how awesome that is, right? There's just so many use cases that have become one-liners where there would otherwise be reams and reams of boilerplate multi-threaded Java code. Okay, so there's my client interaction. That should do it. So let's try and restart the service. Alrighty, up and running. This is the client. Let's restart this one now as well. So the client, as soon as the client connects, when it starts up, it's going to connect to the service, and then the service is going to connect back to the client. And so I'm getting back an infinite stream of greetings responses. At some point, we're going to see not healthy. Oh, there you go. It stopped, right? So I go back to here. That's the integration flow. Let's shut down integration. We're done with it for the day. Okay, and I should have made it more clear. So I'll say do on next CHS system out healthy. Sorry, not healthy, right? By definition, but if it's gotten this far, it's not healthy, right? Good. So now let's restart the service and the client. Okay, restarted the service, now restarting the client. Oops, that was quick. This time we lost the lottery. Almost the first round, we got a non-healthy object. So we got one response, and it printed out not healthy immediately, right? Okay, let's try again. Hopefully we'll get better luck this time. There you go. Oh, got 2 in, right? So you can see what's happening there. I get a few results in. Seems like I'm getting in the 20% range for some reason, right? Not my lucky day. 1, 2. There you go. I've gotten a few responses as a client, right? And so far I'm okay. But what if I were to what if this node, I'm running this client over here on the right-hand side of my screen, and then what if I decided to run Slack? Suddenly I've got no memory, no power, so the health is really bad, and so it says, hey, not healthy, and it stops trying to stream the data, right? etc. So I love that. I love that you can do this kind of bidirectional communication. It's not just message in or message out. It's not just message in and stream out. It's not just stream in and stream out. It's not just fire and forget. It's actually all of that in either direction at either time, and anybody can initiate the conversation, right? This makes it so you have a really rich possibilities. Now, that said, everything I've been doing thus far has been assuming the best, right? Now, I'm using a client here. I'm using a regular RSocket service and a regular RSocket client, and these things are talking to each other directly. You don't have to do that. There's actually a broker you can use. Now, this is not yet GA. It's not yet, I'm not going to show it to you, for example, so it's not yet 100%, but the idea is that you can use this RSocket broker. This RSocket broker acts as a sort of hub, and you can have a broker sat in your architecture. The broker sits out there accepting incoming RSocket requests, and then it forwards the request to a service that's available, that's healthy and able to respond to it. RSocket has in its protocol frames a frame dedicated for information about the state of the service itself, about the health of the service itself. How many of you have ever used Actuator, I wonder? I can't see your hands, but I hope that if you've ever used Spring Boot, that you're also using the Spring Boot Actuator. Now, Actuator are a set of managed HTTP endpoints that give you information about the state, the health, the uptime, the metrics, all that kind of stuff that's related to the operational health of the service itself. And who better to articulate that state than the service itself, right? Obviously, your platform, be it Kubernetes or Cloud Foundry or whatever, or Heroku or whatever, or Google Cloud or whatever, it's going to have some sense of your application's health, but it's going to be pretty opaque, right? It's going to know about RAM and CPU usage, and that's it, right? It's not going to know whether it really is in trouble or not or in distress beyond those very, very vague operating system level signals. The actuator gives infrastructure, outer infrastructure, information it can use to figure out how busy or available or responsive a service is. And a client, a smart client, can use that information to say, hey, looks like you're super busy. I'll come back later. Thank you for answering my question, right? And it can load balance to something else. It can self-select into another instance that has less demand. This makes it trivial to do some very interesting things if you know about the actuator. But keep in mind, the actuator is just a sort of it's a Spring Boot-ism, right? It's a thing that people in the Spring Boot community know about and hopefully embrace, but it's not, you can't take it for granted with all HTTP services. Furthest thing from it, right? It's just a thing that happens to be something that we support in the Spring Boot community. However large that is, it's still not everybody yet, right? I'm working on it. So wouldn't it be nice if the service protocol, the protocol in which you express your services, understood how to tell others its availability, its health, its state, its metrics, etc.? RSocket has that, right? It actually has a metadata frame for that. So this is one more example of where RSocket is, more built for production. And so that's kind of like a reverse back pressure. Instead of the client pushing back, that's why we call it back pressure, because the client pushes back on the producer, the consumer pushes back on the producer. Instead of the client pushing back on being given too much data, in this case, the service says, hey, I can't give you anything. Don't even bother asking, right? And so in this case, both ways achieve the effect of making sure that you're not overwhelming one side or the other with data that it can have, right? Because in the original back pressure use case, which is super important, we assume that the service is big and beefy, and we assume that the client is small and easily overwhelmed. But that's not always the case. It might be that the client is just one thread, whereas the service is dealing with 1,000 different things going on, right? And it may very well be starved of resources and unable to respond. So RSocket gives you both directions. It gives you metadata in both directions. And if you have this hub, that hub can use this reverse back pressure to express this idea that, hey, you've connected to me as a hub, and I'm trying to proxy you. I'm trying to route your request to a downstream RSocket service, but they're all busy. I asked, they're all busy, they can't handle you, so I'm going to give you 100% back pressure. I'm going to push back. You're not going to be disconnected as a client. It'll still look like you're connected, but there's going to be a delay, right? And as soon as something becomes available, believe me, I'll connect you, I'll patch your way through, and you'll be the first one in the queue to get that request into that downstream service. So it can act as a load balancer, right? Very, very smart load balancer that actually understands streaming semantics as opposed to just memory and CPU, okay? So this broker's one has some other opportunities as well. Imagine now that you understand how RSocket kind of works, and you know that services connect at the startup and then they just stay connected. Well, that means that some very interesting possibilities happen. That means that at startup time, once your services have connected, that's the topology. That's it, right? So that's not going to change. If I have 10 services in the architecture, barring some unforeseen thing where they disconnect or they fail, I know what services are out there. I know what requests I can expect. And I know, too, where I would need to send those requests because I have a live socket to those services. And so as a hub, I can take a request from the outside. I can then take one of these live connections and send the request to the downstream service, get the response, and then send it back to the client connecting to my hub. But I don't have to open my firewall to do that. The RSocket client, the RSocket service to which this hub forwards the data is already connected. It's connected once. You can have completely black box, no ingress whatsoever on these RSocket services. It's already connected just once for the RSocket hub, and that was an authenticated connection, and that's it, right? So obviously you should have some security, obviously, but it really, really helps when you reduce the surface area for attacks and things like that, right? So here we're saying there's absolutely no way into this beyond the initial connection that the RSocket service itself made to the RSocket hub when it first started up, and that was done in an authenticated TLS encrypted way, right? So very, very interesting opportunity there as well, this hub. And this hub is a project that we're building along with other people in the Reactive Foundation. So the Reactive Foundation is a organization that was jointly launched by the Spring team and, of course, Lightbend and, of course, Facebook and, of course, Netflix and, of course, Alibaba. Right now, Alibaba is another large organization along with Netflix and Facebook that use Spring and use Reactive APIs at scale, huge scale, right? And so it was natural for all of us to get together. And one of the things we donated to the Reactive Foundation is RSocket. We also donated R2DBC. So RSocket is a joint thing. R2DBC started on the Spring team. It's a reactive relational database connectivity abstraction. All of these things now live in the Reactive Foundation. And one of the things that we're starting to build together is this reactive RSocket broker, right? So that's an interesting opportunity. But for now, my friends, we've got one client, one service. And speaking of security, I think we should have some security. I think we need to add security to this service. So what I'm going to do is I'm going to use Spring Security, and I'm going to just configure a simple, Matt Rabel cries and beer inducing username and password example. Now that said, RSocket has JWT support, so you can do dot authentication. So map reactive. Oh, I need to re-enable security here. Hello. Okay. Authentication. Turn new map reactive user detailed service, and I'm just going to create a simple security. Okay. With this username, and it's going to be along. That's me. Roles, user, build, and of course I'll add Matt because I trust him implicitly with my data and my life and my beer. Okay, there's this. Bravo. All right, good. So, good. All right. So now I've got I've addressed the question of authentication. Obviously, there's a whole other discussion to be had about reactive security, because remember, cryptography and the like, that requires blocking a thread, right? So Spring Security does a pretty good job of putting that on a separate thread and doing the right thing there, but keep in mind, you're still going to be doing cryptography somewhere. And so you should be using something like JWT or OAuth for HTTP, because that has the effect of moving some of the tedious thread blocking cryptography to another authorization service, which can be scaled out to something like, Okta, right? So that's a very, very natural fit. You're not paying Okta just for world-class leading security. You're paying them for CPU cycles. You're making them do the expensive cryptography so that your code can scale and be blissfully ignorant of that particular thing. So the next thing is authorization, right? So here we're going to say we're going to lock out parts of the application. We're going to say only certain things can access certain parts of the system. And so I'm going to use an RSocket security object. And this should look fairly familiar if you've ever used the security web filter chain in Spring WebFlex or in Spring MVC. I'm saying any exchange has to be authenticated, which I think, by the by, is actually the default, so that works out. I could, like I said, I could use Jot, but I don't have time to set up all the keys and all that stuff. So instead, simple authentication and customers, and then voila. Okay, there's my RSocket authorization. Now that's going to give me 90% of what I want. Actually, that does work. My endpoint is now authenticated, but I want to do one more thing. What I want is instead of having a request, I want to get a user details object. And because of there's no good reason. We'll fix this. I want this to get fixed. But in the meantime, it doesn't automatically know what to do when I use the @authenticated. Oh, it's rush hour in San Francisco. I live by the Bay Bridge in San Francisco. And so even though I'm on the 12th floor of a condo building here, you can actually, what you were just hearing was actually noise from the street 12 floors down. So what I want to do is I want to actually inject the current authenticated user. That's a part of the programming model. And so let's imagine I create this new endpoint. I'm going to refactor this endpoint a little bit. Greeting response, greet. Here, I'm going to do that just like before. Authenticated. Okay. Authenticated principal, mono of user details. User details, mono, users. Okay. And here, I'm going to say take the user, map it to a user details, map that user details to a name, and then map that to a greetings request, username, username, and then map that into a request to the actual thing here, the actual endpoint. So here we go. Paste, paste, paste. gr this .greet gr, and the other thing I'm going to send in is the requester. So incoming requester gr, and there you go. That's this. So what is the issue here? Flat map mini. Voila. All I'm doing is I'm just taking the authenticated user, turning it into a greetings request, and then I'm calling the existing code path as per usual. So this is, I can make this private, right? It's just a slight, that's what we used so far. All I'm doing now is I'm adding security. So the greetings request won't be, I don't expect the client to send a greetings request. The greetings request will be empty. I'll create one based on the current authenticated user in tow in the request. And so in order for that to work, I need to teach Spring Security about what to do when it sees an authenticated principal annotation on the component model. Okay, so let's go to our service, and we're going to add a RSocket message handler. And var rmh equals new RSocket message handler. I don't have this. I forgot to do Java 11. Okay, set RSocket strategies. RMH dot I get the authenticated blah, 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 add this new authentication principal argument resolver, rolls right off the tongue, RMH. Alrighty. So there's my RSocket message handler. That's all that does is it teaches Spring Security about what to do when it sees a current authenticated user in the request, and then it sees a parameter annotated with authenticated principal. So that should do it from the service perspective. So let's go ahead and restart that. Okay. And then on the client side, what I want to do is I want to actually configure authentication. So shut this down. Okay. Illegal start of expression. I beg your pardon. Okay, go. Oh, I forgot to do the password. Username. This is the part that where people like my friend Matt and Rob Winch and others hate me. Just hate me. I can feel the contempt. Usernames and passwords in code on stage. What are you doing? Okay, that's fair. So, okay, service is up. Now we need to change the client to be aware of authentication. And so the way authentication works in RSocket is it uses those aforementioned headers. And those headers are, they're a little different than the headers with which you might be familiar. The keys are not arbitrary strings, they're MIME types. Okay, so the association is between a MIME type, which the content negotiation mechanism in RSocket uses to determine how to decode and encode the headers to which they correspond. So here, I'm going to say MIME type equals MIME type utils dot my, okay, well-known MIME type dot this. Okay, so it's an RSocket message RSocket authentication, and the username password metadata equals new username password metadata JLong and PW. Now, don't ever do this ever. It's a terrible idea. You should encode it and encrypt it, or better yet, use JWT. But for now, you get the idea. So I need to communicate this MIME data. This is the header, if you will, and I need to communicate the credential itself at some point. And I need to also teach Spring Security about what to do when it sees this information in the body, how to encode it. I need to teach RSocket how to encode that data. So what I'm going to do is I'm going to configure a RSocket strategies customizer. Okay, customizer X encoder, new, simple, whatever. There you go. So that's part one of it. That's part one. Let's just do that. Okay. And the other thing I want to do is I want to actually configure the credential itself, and I can do this two different places. Remember what I said before? There's an initial connection when the sockets will actually establish the handshake and make the initial connection, and that happens in the RSocketRequester. So I can do that here. I can pass what's called metadata. So headers are metadata, right? So I can say this MIME type, this type username password metadata, right? Or is it the other way around? Yeah, MIME type comes second. Okay, so that's one place I could do it is when at the very beginning of the session. And in this case, if the RSocket if the connection is basically unconnected, or if it's not connected to a particular user identity, it's just like a client credentials only kind of flow and OAuth, then yeah, just do it once. It doesn't matter, right? Maybe this is a batch job or something. I'm connecting to an RSocket service, and I just need to know what the name of the service is. There's no real context associated with a user per se, right? So in that case, that could work. Or you could do it per transaction, right? Or you can do both, by the way. You can also do both. There's no reason you couldn't do both. So I can do metadata here. And this is saying this particular individual request with this particular data is associated with this particular user, right? And that's actually more in line with what people will have used or come to expect, having used HTTP for the last 30 years. So looks okay. I think that's right. Let's go ahead and give it a shot. Class not found. Oh, I didn't have security in here, do I? Spring RetroSocket. I do. What did I do? Off metadata flyweight. Simple. Okay, I've done something weird here, and I have a sense that it might be that I'm using the latest and greatest version of Spring Boot when I should have been using 2.33. So let's just jump back in time a little bit here, make my life a little easier. Fresh. Hey, there we go. Oops. Well, okay. It was not healthy pretty quickly, but it says hello JLong. So the client connected to the service. It identified itself as JLong. The service said, oh, okay, I'm going to send back an infinite stream of JLongs instead of like whatever the greetings request that we have in there. And actually, you can see that that's kind of interesting, right? It's just ignored. I said tjug. That didn't. It was sent. I didn't need to send it. I could have just done this. I could have done mono.empty, which is fine, right? Mono.empty. And the service responded with, I don't care what the data is. I care about what the current authenticated user is. So there you go, my friends. We've looked at a few things today. I wish we had more time. I wish we we've only begun to scratch the surface, really. I mean, this RSocket stuff, it's going to be big. You mark my words. It's already being used at scale by Facebook. You've probably heard of them. Alibaba, that's arguably the second or third largest website on the planet. The Spring team, we've been very quick to embrace it in the Spring ecosystem. I've been doing presentations with RSocket in it whenever I introduce Reactive. It's always at the very tail end of my Reactive presentations. And if you looked at my demos 2 years ago, those demos had raw RSocket, just a Reactor API, right? And then eventually we surfaced this really convenient, very handy add controller message mapping component model that makes it much simpler. And since then we've gone even further. Now you can see there's support in Spring integration and Spring security, and there's a Spring RetroSocket, and there's an RSC client, and there's a broker that's coming along, and you can actually try and use now. All sorts of stuff, right? It's just getting really exciting. And so as all this is happening, these large organizations are leading the way, right? They're now out there saying this is stuff that we use at scale. And you can imagine, right? Imagine like that reactive stream that we looked at earlier. You say, I've got a publisher that's producing data about my timeline or something like that, right? Imagine you're like a Twitter or some sort of social network, and the users on the mobile phone, and they're scrolling through their phone looking at all the new data, and then they go through a tunnel and they're disconnected. Well, if you're doing HTTP, as soon as you get through that tunnel, you've lost your context, so you have to refetch the whole timeline and try and pick up where you left off. With RSocket, with Reactive APIs, with back pressure being able to be communicated over the wire, you just resume. You've requested 10. You haven't requested more. That doesn't mean you've lost your context. It just means you just haven't requested more yet. That's all. It's very simple. So you actually have session resumption with RSocket, which is amazing. The other thing that I didn't really show here because I just didn't is RSocket is actually it's very amenable to running over other transports. So here I'm using the default TCP UDP RSocket transport, but you can run RSocket on top of WebSockets, right? And you can also run RSocket on top of Aeron, which is a very, very fast, finely tuned dispatching framework by Martin Thompson and the other name, it escapes me, but I'm sure as soon as we hang up, it'll return. So you can write. You can use RSocket from the browser. You can use it over WebSockets. You can use it on Android code, right? There are clients in Go and C++ and Java and JavaScript and Node, everything. So this gives you a convenient, commoditized paradigm for building services that works in a natural way across every client. It's idiomatic across each one, of course. It's not going to be, Reactor APIs when it makes no sense from a Go perspective or whatever. But it does work, is my point. And these organizations are using it at scale. There's a C++ binding as well. So really, really interesting opportunity. I spend a lot of time every year, not this year, of course, because, well, it's 2020 and we know why. But I used to spend a lot of time going to organizations, large and small, and talking to them about what we're doing in the Spring ecosystem. And one of them is Alibaba. Every year I go to Hangzhou in China, and I spend a week or more with Alibaba and just see if I can help, just present for as long as they'll have me, and then soak up what they're doing. Just trying to learn what the use cases are, what they're doing with Spring. They've been using Spring for decades, right? It's everywhere. Every service there is Spring and Spring Boot now. And so, in 2012, I went to them and I showed them all the stuff that we're doing around Spring 3.x and the Java configuration and things like that. That was fine. Back in 2014, I went to them and said, "Hey, my friends, you've got to see this. We've got this thing called Spring Boot with my, there I was with my hair on fire. I was so excited. And Spring Boot, as you can imagine, took off. Very, very ubiquitous in that organization. And actually, when I say Alibaba, I'm broadly referring to the umbrella of Alibaba, Taobao, Ant Financial, AliExpress, all these different organizations, Alipay. I mean, all these huge, organizations, each of which would be a very interesting unicorn, I think, at some point here in the Valley, right? Each of these organizations actually are all part of the auspices of Alibaba. And so all of them are using Spring and Spring Boot. And every year I go there and I show them the new thing. Eventually I show them Spring Cloud, 2015. And then 2017, I think, I started showing them all the reactive stuff. And then 2018, I showed them RSocket and the raw stuff. And now here we are all working together, right? Alibaba is actually in the mix, contributing to this. They're all in on Spring. They're all in on Reactive. They're all in on RSocket, right? Which is crazy if you think about it, right? The ability to have something so phenomenal that it changes, it implies such a sea tide change for an organization as large and already very successful at scale as Alibaba, as Facebook, as etc. It's a wonderful situation. I thank you all for your time, my friends. As usual, it's a pleasure to see you, although I didn't get to see but two of you today. And I hope you're all healthy and happy. And all right, back to you guys.
All right, so we do have a question here.
Yes.
That they asked, Matt Henry asked a while ago, and that is, how will Spring Reactive be impacted by Project Loom?
It'll be awesome. So Loom is just a lightweight thread pool, right? That's going to be good. You're still going to need a control flow mechanism, a data flow, component model. So that's what Reactive gives you. Reactive gives you a way to say, I have a stream of data. I want to filter it, map it, those kinds of things. And same thing for, I showed you some of those. I showed you the scatter gather kinds of opportunities in the code base. That wouldn't be easy. Again, you would have to write threaded code to get that kind of result, whereas it just becomes a very simple thing with these operators in Reactor. So I can't wait for Loom. Loom will be another scheduler that we can use behind the scenes for these Reactive APIs.
Nice.
I'm excited.
So you're lucky because there wasn't any other questions beyond that. So we'll let you get back to your evening, enjoy it, and thank you so much for coming and joining us.
Hey, buddy, thank you. Can I take a selfie?
Of course.
Okay, I've got to figure out how to get my screenshot working because it's, okay, hold on. New keyboard. Can you do it and just send it to me? Like, it's bringing up expose, and I've got this new keyboard and it's goofy.
I got it.
Thanks, bud. Oh, wait, do it again, one more time.
1, 2, 3.
Okay. All right, everybody.
All right. See ya. Thanks for coming, y'all.